Hi everyone and welcome back to Educlynk. So today we are going to see chapter 2. Chapter 2, chemical bondings. In chapter 2 we are going to see lesson 1, introduction to chemical bondings. Lesson 2, type of chemical bonds. Lesson 3, shape of molecules. Lesson 4, intermolecular process. We are still under module 1, which is matter and transformation. So we'll go straight to the point. A chemical bond, so the definition. Definition. A chemical bond is any electrostatic force of attraction that exists between two or more atoms or ions in a given substance. So, a chemical bond is any electrostatic force of attraction that exists between two or more atoms or ions in a given substance. So the chemical bond, first of all, is electrostatic in nature and it exists between two atoms or ions in a given molecule or a substance. So there are three main types of chemical bonds. So the three main types of chemical bonds include types of chemical bonds. Wow. An ionic bond, covalent bond, lastly, a metallic bond. So there are three main types of chemical bonds. We have an ionic bond, a covalent bond, and a metallic bond. So you can go A, ionic bond. An ionic bond is any electrostatic force of attraction that exists between oppositely charged ions. Example, we can have a compound like, say, sodium chloride. So in this case, the ionic bond is between the metal, that is sodium, and the non-metal, that is chlorine. So doing ionic bond, there will be the transfer of electron from the metal to the non-metal. So at the end of chemical bonding, the metal is positively charged, while the non-metal is negatively charged. Why? Because the metal is losing electrons, while the non-metal is gaining electrons. So let's illustrate the ionic bond in sodium chloride. Illustration. So to illustrate the ionic bond in sodium chloride, we start by writing the electronic configuration of the elements in the compound. The sodium chloride is made up of sodium, atomic number 11, configuration 2:8:1. Chlorine, atomic number 17, configuration 2:8:7. While illustrating chemical bondings, we always need to use the 2:8:2 formula or configuration. So it's not advisable to use the SPDF notation because using this, they actually showing the number of electrons present in the outermost shell. In this case, we realize that sodium has 1 electron in the outermost shell, while chlorine has 7 electrons in the outermost shell. So sodium being the metallic sodium would transfer its valence electron to chlorine. So let's do the bondings. So we have sodium has 1 electron in the outermost shell, plus chlorine instead have 7 electrons in the outermost shell. 1, 2, 3, 4, 5, 6, 7. The transfer of electron is done from the metal to the non-metal. So the sodium atom lost its valence electron. So yes, before bonding, after bondings, the sodium metal, I am using the outermost shell. In the outermost shell, there's 1 electron. For chlorine, the outermost shell is 7 electrons. So the electron is being transferred from sodium to chlorine. At the end of the day, the sodium atom lost its electron. So sodium now, the outermost shell is empty. It becomes now positively charged. The configuration is 2:8. Why? Because it has lost its valence electron to chlorine. It has lost only 1 electron. That is why the charge is positively charged. The chlorine atom gained the electron from sodium. So chlorine, it gains the electron from sodium. 1, 2, 3, 4, 5, 6. So it's 8. It's 8. Chlorine minus. So the chlorine now becomes negatively charged. Why? Because chlorine has accepted the electron from sodium. So this is what happened during chemical bondings. So here should be after bondings. After bonding. So what's the physical significance of this? The ionic bond actually is the opposite, the electrostatic force of attraction. You see, we have the attraction between sodium plus and chlorine minus. So we have an electrostatic force of attraction. From the law of electrostatics, unlike charges attract. So the sodium plus attract the chlorine minus. So we are going to take another more complex example. So zero example 1. We're illustrating an ionic bond in sodium chloride. So we'll take another example, a typical example like, let's say, magnesium chloride. So magnesium chloride. So example 1. Magnesium chloride. Example 2. Magnesium chloride. So magnesium chloride is made up of magnesium and chlorine. But we don't just have 1 atom of chlorine, we're having 2 atoms of chlorine. So it means the stoichiometry is 1 magnesium is to 2 chlorine. So what the physical significance of that is? It means 1 atom of magnesium is going with 2 chlorine atoms. The very first step is to write the configuration. So magnesium atomic number is 12. Let's listen to magnesium atomic number is 12. So it's 2:8. It's to 2. Chlorine atomic number is 17. 2:8. It's to 7. We realize that magnesium has 2 electrons in the outermost shell. Chlorine on its own have 7 electrons in the outermost shell. So we write our magnesium atom. In the formula, there's only 1 magnesium. So write magnesium Mg. So yes, Mg. Okay. In the Mg atom, there are 2 electrons in the outermost shell. I put it 2 electrons. Plus chlorine. There are 2 chlorine atoms. So write the 2 chlorine atoms. So having chlorine, chlorine. Chlorine has 7 electrons in the outermost shell. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Here's the chlorine. Remember that during an ionic bond, electrons move from the metal to the non-metal. So electrons move from the magnesium, that's Mg. It goes to chlorine. It also goes to chlorine. At the end of bonding, we are going to have magnesium is losing 2 electrons. Remember, when you lose 2 electrons, the charge will be 2 plus. So a plus in chemistry means you have lost electrons. So the magnesium atom now will be Mg. Mg 2 plus. So the magnesium ion now is carrying a charge. That's 2 plus. Because magnesium has lost 2 electrons. So the configuration now of magnesium, given that it has lost these 2 electrons, the configuration now will be what? 2:8. I think 2:8 configuration. Then chlorine. Chlorine. There are 2 chlorines atoms, such that chlorine plus chlorine is Cl2. There are 2 chlorines. So put 2 here. Showing that because there are 2 chlorines atoms. But each chlorine atom is gaining 1 electron. So here there's chlorine. 1, 2, 3, 4, 5, 6, 7, 8. Chlorine is negatively charged. Why a single negative charge? Because each chlorine atom gains 1 electron. That is why we're having this configuration. So chlorine and the configuration of chlorine or the chloride ion will be 2:8:8. Why? Because this chlorine is gaining 1 electron from magnesium, given that there are 2 of them. We have 2 electrons in the outermost shell. These 2 electrons are being transferred to the chlorine atom, such that each chlorine atom gains 1 electron. The configuration of chlorine or the chloride ion becomes 2:8:8. The magnesium now is 2:8. Why? Because magnesium has lost its 2 electrons in the outermost shell. So the next example, we're going to take an example of an oxide. So because I've been seeing chlorides ever since, we saw sodium chloride and magnesium chloride. Now we're going to see an oxide, an example of an oxide. So, oxide. Oxide. So the oxide will be like example 3. Oxide. So let's take an oxide of group 2. That's calcium oxide. Calcium oxide. In this case, the compound calcium oxide contains 1 atom of calcium and 1 atom of oxygen. So we'll clearly start with the electronic configuration of the elements. So our calcium, the atomic number is 20 for calcium. That's 2:8:8:2. We clearly see that in the outermost shell, there's 2 electrons in the outermost shell. There are 2 electrons. The one of oxygen, so having oxygen, atomic number for oxygen is 8. That's 2:6. Oxygen has 6 electrons in the outermost shell. Otherwise, oxygen needs 2 electrons to attain the noble gas configuration. So the main aim of chemical bonding is that at the end of the day, this element should have the noble gas configuration. That is 8 electrons in the outermost shell or 2. So the calcium atom will lose its 2 electrons from, at the end, we're going to have calcium 2 plus because it's losing 2 electrons. So let's go to the bonding. Having, yes, before bondings, we're having calcium. So yes, before, having calcium with 2 electrons in the outermost share, plus oxygen, 1, 2, 3, 4, 5, 6. Having oxygen with 6 electrons in the outermost share. Then the calcium atom transfer its electrons to the oxygen atom. I am using the outermost share to carry out my chemical bondings. In the outermost share for calcium, there's 2 electrons. For oxygen, there are 6 electrons. So the dot is for O and the cross is for calcium. At the end of the day, we're having calcium. Calcium, the charge for calcium is 2 plus. Why? Because the calcium atom has lost 2 electrons. That's why the charge for calcium is 2 plus. Let us now see the charge for oxygen. The oxygen atom gains 2 electrons from calcium. So having X, 1, 2, 3, 4, 5, 6. The configuration for calcium dropped to, because these 2 electrons been lost. The configuration now dropped to 2:8:8. That's what I told you guys earlier, that elements undergo bondings to become stable. So in real life situation, elements or people, they gain their stability by getting married. It's the same thing here. So elements, they bond with other elements attaining a noble gas configuration. We all know that the noble gases are the most stable element in the periodic table because the outermost share is completely filled. The oxygen atom now, the configuration will be, because this 2 electrons is given here, is going to be 2:8. Then what about the charge for oxygen? Oxygen has gained 2 electrons. The charge now is 2 minus. 2 minus. So those are the chemical, that's the chemical bonding. We did the chemical bondings for sodium chloride, magnesium chloride. Now I'm doing for an oxide, which is calcium oxide. Okay, what is the similarity between all these compounds we have done? Is that at the end of the day, the metal is positively charged. The non-metal is negatively charged. Be it -1 or -2. But the most important is that there is an electrostatic force. That means the force of attraction is between the negatively charged metal, non-metal, and the positively charged metal. So there's a force of attraction between the two. Then what are the consequences of compound having ionic bondings? So that is what we are going to see right now. The properties of compounds with ionic bonds. Properties of compound. Properties of compounds with ionic bonds. Having this compound conduct electricity in a molten state. Why? Because the compound have free mobile ions. That is why ionic compound are used as electrolytes. Let's take the case of the sodium chloride that we saw earlier. Sodium chloride ionized in solution to give sodium plus chlorine minus. So these charges are free to conduct electricity. So in solution or in a molten state, this compound, this ionic compound, are good conductor of electricity. So the second property is that they are white crystalline solids at room temperature, just like the salt, the common salt you eat in the house, or the table salt. They are white crystalline solids. Next, they are brittle They are brittle due to the fact that the crystal lattice is not too strong, and they are brittle. The next, they ionize in solution or dissolve in polar solvent like water.